What's going on, guys? Welcome to the next video, and in today's video we're going to be talking about how to integrate a bunch of different functions that are related to the cotangent and the tangent functions. Now, in the previous examples we saw how we can find the functions or the integrals of the functions tangent and cotangent by using a common general formula that we derived a few videos ago, and it is that if we're able to express the function as a rational function where the numerator is the derivative of the denominator, then we know that this is going to result in a natural log of f of x plus the constant c. And we arrived at this result simply by looking at the general function natural log of f of x and differentiating it to get this expression. So now we're going to apply that general result to a bunch of different examples that are much more difficult than what we have been dealing with so far. Now, for the first one, we start off with, we have a polynomial function here, 2x plus 1, and it is multiplying the cotangent function x squared plus x minus 10. Now, it looks very intimidating, but the first thing we should do is we should probably change that cotangent function into things that are more familiar to us. And in this case, we're just going to change that into the following function. So we have 2x plus 1, and then over here we're going to end up with a cosine of x squared plus x minus 10 divided by sine of x squared plus x minus 10. Okay, so we're just substituting that by a simple ratio of sine and cosine. So that's a little bit more familiar to us. And the next thing is we're going to see if there is such a relationship between those two functions here as the one that we need. So let's differentiate the function. In the denominator we have sine x squared plus x minus 10. Now what are we going to get from that? Well, we're simply going to get the derivative of the argument, which is 2x plus 1, and that's going to multiply the derivative of the outside, which is a cosine function, and that's going to contain x squared plus x minus 10. Okay, so that's essentially what we're going to have here. Now, since we already know that's exactly what we have in the numerator, then we can proceed and integrate as usual. So we know that in this case, we're going to get the natural log. So we have a natural log of the denominator of the function. Okay, so that's a final result, and then we're going to add the constant c. So that's a final answer. So we dealt with this integral in a very elegant manner, and we only required about 3 steps to do so. Now let's jump into the next example. This one is a little bit less obvious because we now start off with a rational function. So the first thing we're going to do is, as usual, let's replace the tangent function by sine and cosine. So we're going to end up with the following. We have 1 over the square root of x, then sine of 1 plus the square root of x, divided by cosine of 1 plus the square root of x. And if we look very closely at this, it looks like the numerator is the denominator of the function that we have here. So let's start off by differentiating that cosine function. We have cosine 1 plus root x. Now, as before, we can apply the chain rule. So let's differentiate the argument first. That's going to be the square root is going to become a half x, and then subtract 1 from the power, that becomes to minus half. And then the cosine becomes a minus sign, so let's put a minus at the front, and then we have sine 1 plus root x. Okay, now if we write that in a bit of a cleaner form, we have 1 over 2 root x sine of 1 plus root x. Okay, so that's the derivative of that function. If we look very closely, it looks like we already have that except for a factor of minus half. So what we're going to do to fix that is we're going to have a minus 2 at the front of the integral, and then we're going to place a minus half inside. So we have 2 root x, and then we have sine of 1 plus root x divided by cosine of 1 plus root x dx. And now the next step is going to be as usual. We're just going to integrate that using the fact that the numerator is the derivative of the denominator. And in this case, by denominator, I just mean the cosine function, as we just saw. So that's going to turn out to be minus 2 times the natural log of cosine of 1 plus the root of x plus c. Okay, so that's going to be our integral there. So we started out with a fairly complicated expression, and by making the right substitutions, we were able to get it into this form. And now for the final integral that we're going to do related to tangent and cotangent functions, we're going to look at a very, very interesting one. We have cosine multiplied by a tangent, but there's a sine function inside of the argument of the tangent function. So that looks very, very tricky to do. So let's just guess what that's going to look like. Let's replace the tangent function by a simple sine over cosine. So we have sine of x divided by cosine of x dx. And now we're going to test whether the denominator differentiates into the numerator. So let's start off with the derivative of that function. We have cosine with sine of x as its argument. And that's going to require us to apply the chain rule of differentiation again. So now what we're going to have is, well, we apply it to the inside argument first. That's going to become a cosine x. And then we apply it to the outside, which is going to become sine. Actually a minus sign, so let's have a minus at the front. We have sine of x, just like that. And if we compare that to the expression we have here, it looks like it's exactly the same, except we're missing that minus sign. So to fix that, we're going to place a minus sign in front of cosine, and then we're going to put a minus sign on the outside of the integral as well, just to make it consistent. So now if we take all of those results into account, we can write down the final answer as follows. We're going to have minus the natural log of the function in the denominator, which is cosine of sine x. And make sure you include enough brackets, and that's going to be plus the constant c. And that's basically it. There you have it. You have successfully integrated a bunch of trigonometric functions multiplied together when one of them is the argument of another one. And we did this using the exact same result we have been implementing in the past few videos. So in the next video, we're going to continue with more integration techniques. And as always, if you guys enjoyed this video, make sure you hit the subscribe button if you would like to see more content from LetThereBeMath. And I will see you guys in the next video.